Hello friends, in our last video we concluded that numbers that can be represented of the form p by q are rational numbers and the numbers that cannot be represented in that form are irrational numbers. We also learned that both rational numbers and irrational numbers together are known as real numbers. Now let's try to represent these real numbers on a number line. Since we already know how to represent integers on the number line, let us try to represent rational numbers other than integers. That is, let us try to represent number such as 1 by 3 on this number line. But what does the number 1 by 3 actually indicate? 1 by 3 is nothing but one part out of the total 3 parts. So to represent the number 1 by 3, we divide the line segment between 0 and 1, whose length is 1 unit, into 3 equal parts. Now, this is the one part out of the total 3 parts. So, the length of this part is 1 by 3 units. As we are starting from 0, this point will be 0 plus 1 by 3, which is 1 by 3. Now, these are the 2 parts out of the total 3 parts. So, this point will be 2 by 3. And finally, this point will be 3 by 3 since these are the 3 parts out of the total 3 parts, and so this point will be 1. But how can we represent a number which is greater than 1 using the same method? That is, how can we represent a number like 7 by 5 on the number line? For this, we will write the number 7 by 5 as 1 plus 2 by 5. That is, in mixed fraction form. We can clearly see that the number 7 by 5 lies between the integers 1 and 2. So on the number line, instead of starting from 0, we will start from 1. That is, we will divide the line segment between 1 and 2 into 5 equal parts. Now, this point is 1 plus 1 by 5 and this point is 1 plus 2 by 5, which is our required point 7 by 5. So this is how we will represent any rational number on the number line. Now coming to irrational numbers, let's see how we can represent square root of 2 on the number line. This number comes up whenever we consider a right angle triangle whose both legs are 1 unit in length. Let us name this right angle triangle OAB and draw this on the number line. The base OA will be on the number line with its length equal to 1 unit. So O is at position 0 and A is at position 1. Now we will draw another leg of the right angle triangle with the same length 1 unit and name it AB. Now joining OB, we get the right angle triangle of hypotenuse square root of 2 units. Now, this length of hypotenuse is what we have to represent on the number line. With the help of compass of radius equal to OB, we will represent square root of 2 on the number line. Now, how can we represent the irrational number square root of 3 on the number line? For this, draw a perpendicular line to OB of 1 unit length and name it BC. Now we will get a right angle triangle OBC with the length of OC equal to square root of 3 units. Because in right angle triangle OBC, OC is equal to square root of 2 whole squared plus 1 whole squared, which is square root of 3 units. Again, with the help of compass and using the length of OC as the radius, we will represent square root of 3 on the number line. In this way, we can represent the square roots of the natural numbers on the number line. There is one more method of plotting square root of 3 on the number line. It is quite similar to the previous method. Since we have already plotted square root of 2, we know that the distance between O and D is square root of 2 units. Now, draw a perpendicular of length 1 unit from D. If we join OE, we will get a right angle triangle ODE in which the length of the hypotenuse is square root of 3 units. Now, this length of the hypotenuse is what we have to represent on the number line. With the help of compass of radius equal to OE, we will represent square root of 3 on the number line. If you observe carefully, for representing square root of 3 on the number line, we made use of the representation of square root of 2. Similarly, if we have to represent an irrational number square root of n, we have to make use of the representation of square root of n minus 1. Now, there is another way of representing rational numbers and irrational numbers, and that is a decimal way of representation. And that's what we will be learning in our next video. Till then, stay tuned.